Welcome, technology enthusiasts. Before your eyes is a water spaceship. Crafted entirely from ultra-lightweight pressed foam, combined with a bicycle frame. The heart of its power is a brushless electric motor, with a massive output of 6,000 W, cooled by a circulating copper pipe system, generating incredibly impressive thrust. Starting the building process, the mechanic uses a tape measure to mark the EP's foam board, which is high density. A utility knife and a square ruler are used to cut the foam modules. A specialized adhesive is applied evenly across the surface. The foam blocks are pressed tightly together. The mechanic uses various tools, from wrenches to adjustable spanners, as weights for adding pressure, ensuring the glued joints are completely secure. The large foam block is now basically shaped. The aerodynamic curves of the hull are carefully sketched with a blue marker. Using a wooden stick as a stopper, the edges of the hull are trimmed precisely. Next is the sanding process, shaping the beveled edges of the hull. A large hot wire cutter is fabricated, utilizing current from an arc welding machine. The rounded edge of the bow takes shape and is sanded, perfectly smooth, down to the last millimeter. The higher the surface finish, the more the water friction drag is minimized. To solve the problem of mechanical durability, the entire foam surface is completely covered with a layer of cross-woven reinforced fiberglass. Epoxy resin is rolled on evenly, penetrating deeply, to create a composite shell as hard as steel yet ultra-lightweight. The layer of putty is skimmed thinly to fill in any remaining air bubbles. The steel propeller shaft tube system features pre-welded metal flow-directing fins, heating the steel tube with a torch to pierce directly into the foam core, melting it instantly. This shaping technique is incredibly smart, adding wooden strips to reinforce the hull's edges. The two aerodynamic side wings are measured, beveled, and press-glued into shape, creating the spaceship profile. They are then coated with a second layer of composite for structural reinforcement. Peak creativity is shown when repurposing the bottom bracket and rear fork of a mountain bike frame. The metal frame is recessed into the hull, permanently locked in place with fiberglass and high-strength epoxy resin, creating an incredibly sturdy pilot seat. Covering the entire surface with an oil-based gray primer for seawater waterproofing. The aluminum bike frame parts are spray-painted matte black, giving them a strong mechanical feel. Carefully masking with tape, using masking tape to create the paint border lines. 5. Applying an extremely eye-catching sporty orange and blue color scheme. The stainless steel propeller shaft is greased with heat-resistant lubricant, waterproofed, and skillfully threaded into the steel tube system at the bottom of the hull. For the key part of the drivetrain, the mechanic disassembles the reduction motor assembly with its planetary gears, using a hex wrench to loosen the bolts, and the drive sprocket is removed for fine-tuning. The shaft core needs to be remachined to accommodate the thrust load of the water. A coaxial coupling is being lathed to absolute precision on the lathe chuck, securing the metal. An angle grinder is used to cut keyways to prevent slipping on the shaft head, reassembling the planetary gear sprocket assembly into the aluminum housing of the drive motor. C. The lathe continues to drill a centering hole. A steel flange is face lathed for a smooth finish, and center drilled on the lathe. A high-speed steel drill bit pierces through the metal block, creating an absolutely precise shaft hole. The 6,000 W brushless motor is revealed. The mechanic carefully installs a rubber seal into the shaft tube, preventing seawater from entering the inner engine compartment. A universal cross joint is used for flexible connection. The motor shaft and propeller. The steel motor mount is arc welded very securely. The propeller, a brass propeller, is tightly secured to the tail shaft, testing for smoothness. Placing the motor block in the copper cooling tube system to fit perfectly into the hull. Using a drill to tightly screw the engine mount in place. Next, the bicycle handlebar is installed onto the A-arm steering column. A small steel bracket is screwed in as a fulcrum for the steering cable. The galvanized steel cable is threaded through the conduit, to create a mechanical steering system, transmitting power directly from the handlebar down to the rear rudder, extremely smoothly. The rear rudder shaft is secured with bolts and rubber shock-absorbing pads. The T-shaped lever mechanism is tightened using locking pliers and a wrench. 2 steel cables from the bow are pulled taut and firmly locked to the rear bracket, starting to weld the high-current banana plugs for the 3 phases of the electric motor. Heat shrink tubing is heated to seal the solder joints and prevent short circuits. A 12 volts diaphragm water pump is installed and connected via silicone tubing to the copper cooling coil. The stainless steel water intake pipe is positioned on the side of the hull using screws and plastic zip ties. The electronic throttle assembly, in the form of a potentiometer, is firmly secured to the handlebar. The signal wire is routed along the frame and neatly tied with zip ties. The high-capacity lithium-ion battery pack, encased in a waterproof stainless steel box, is placed into position, connecting the main power supplies. All excess wires are neatly trimmed off. Let's admire the beautiful mechanical and electronic system inside the spaceship. Neat, powerful, and highly technical. Testing a light throttle, the motor roars and the propeller spins rapidly. The water cooling system and the universal joint operate smoothly. It is ready to be launched into the water. The most anticipated moments. The foam spaceship glides on the water with terrifying acceleration. 1. The 6,000 W motor tears through the river surface, leaving a trail of white foam behind. 2. The dual cable steering system allows for extremely sharp turns with incredible stability. 3. The perfectly aerodynamic design helps the hull gently cut through the waves and glide smoothly. 4. The drone camera angle shows the speed and agility of this homemade machine. Speeding past aquaculture cages, the foam spaceship glides like an arrow, an engineering masterpiece made from seemingly the simplest materials. The overhead camera angle fully showcases the spaceship's spectacular acceleration capabilities. The bow cleanly slices through the water, minimizing hydrodynamic drag as it glides. The bicycle frame system provides an extremely sturdy and comfortable seating posture. The pilot can easily control the center of gravity and weave through narrow bends on the river. Absolute precision in navigation when passing through the narrow gap of a concrete sluice gate. A perfect combination of the 6,000 W electric motor and the ultra-light foam hull achieves an ideal power-to-weight ratio, optimizing drivetrain performance. Leaving behind a thick wake, the homemade machine proves its incredible durability, with no signs of shaking or instability. Despite running at high speeds continuously, the layers of composite materials are fully maximizing their superior mechanical properties. The hull grips the water extremely well during turns, perfectly preventing flips thanks to the hydrofoil design. Changing to the point of view camera angle, visually experiencing the sensation of speed from the pilot's perspective. The electronic throttle responds instantly to every command, with zero lag. The electric motor operates extremely quietly, with only the sound of water parting and wind howling. The water cooling system continuously cools and protects the lifespan of the stator coils. A dash cam, mounted on the bow, capturing the absolute stability on the surface. The 2 bike frames completely absorb minor vibrations, turning it into a business-class cockpit. We can clearly see the tension in the steering cables every time the handlebars are turned. The wide-angle drone footage once again confirms the project's resounding success. Gliding past the red navigation buoys, the homemade machine gently blends into the landscape. From rough foam blocks, an old bike frame, and a separate electric motor, through the hands of a gifted mechanic and a masterful engineering mind, it has been transformed into a masterpiece. An electric spaceship, showcasing the limitless, creative spirit of the engineering community. And this incredible machine will continue its journey to conquer new waters.